Hello and welcome to Algebra 1 Exponential Functions, Growth versus Decay, and Key Features of Graphs. In this video, we are going to identify, graph, and interpret exponential functions that model exponential growth and decay, then identify some key features. So we're going to identify exponential functions based on tables and scenario descriptions, and then we're also going to identify y-intercepts and behavior, domain and range, asymptotes, and then talk about whether our graphs are increasing or decreasing, or positive or negative. These are some of the standards that we're going to be covering in this video. These are the Florida B.E.S.T standards for mathematics. So let's do a quick recap of what we know about linear functions, and then we're going to get into our exponential functions. So with linear functions, the form that most people are familiar with is this y equals mx plus b. And with linear functions, we know that they are either increasing or decreasing by the same number or a common difference. So if I look at my table that I have here, the x's are all increasing by 1, so they're all increasing by the same interval. And then when I look at the y's, I can see that we are adding 3 every time. And so with linear functions, we're either going to be adding or subtracting the same number. And so we're going to have a constant rate of change, also known as our slope. And so if I plot these points, I can see that I have a straight line going here, no curves, no breaks, okay? And so with linear functions, they're going to be straight lines with no curves, and they're going to be increasing or decreasing by that same amount. So we can see that it's going up 3 over 1, up 3 over 1, up 3 over 1, and so forth. With linear functions, we could also have horizontal lines. And so you may also see this as y equals a number. When our slope is 0. You could also see this in standard form and point slope form, but they can all change to y equals mx plus b or slope intercept form. Now, the only one that's kind of tricky are the vertical lines. So with vertical lines, yes, they are straight lines, but technically they're not going to be considered functions because we have repeating x values, and it doesn't pass the vertical line test because it is a vertical line. So with vertical lines, that's a little bit different. With exponential functions, now that we kind of recapped on linear, exponential functions, we can see here that these are growing more than just by the same number. If I was looking at this, this is only increasing by 0.25, but then when I'm looking at 0.5 to 1, it's growing way more than that. So with this, we can see that we are multiplying by 2 every time. And it's super important that when you guys are looking at tables, that you're not just looking at 1 or 2 points. You want to make sure that you kind of have multiple points that you're looking at. Whenever I'm doing exponential functions, I normally go from -2 to +2 for my x values and find the y's, just because there are times where it could look linear if you're only looking at a couple numbers. So you just want to be sure, and so go ahead and go from -2 to a +2. Those are some safe numbers you can go by. And so with exponential functions, we're now increasing or decreasing with a common ratio. So that means you're either going to be multiplying or dividing by the same number to get the next y. And so with this one is y equals b to the x. So obviously it's called exponential functions because we have an exponent now in our form. And then it's going to curve. So if I plot these points, this is what it's going to look like. And so notice that if we only plotted maybe the first 3, it could look a little like a straight line, but to be sure, when we added on more points, we could see that it is just sweeping up and getting larger and larger and larger. So it's going to have that curve to it, that exponential curve. And so that's going to be your biggest hint as to whether a table is linear or exponential. You're going to see where that y gets bigger faster. So now let's go ahead and take a look at some scenarios. So scenario 1, it says Mel has a home library of 200 books and adds 5 books every 2 months. So he's adding the same number every 2 months. And so this is going to be linear. Okay, he has that common difference of 5 books every 2 months. Scenario 2 says every year a race runner lizard population declines by 8%. And so with population, it's almost always going to be exponential. So anytime you hear about population, bacteria, things like that, it's usually going to be exponential. Now, when we start talking about savings accounts and banking accounts, that's where you kind of have to be a little bit careful because sometimes they're linear and sometimes they're exponential. So we'll get to those in a second. With scenario 3, it says the average car's value depreciates by 15% each year. So it's not 15% of what the car's value was at the beginning, is 15% of whatever the value is at the end of every year. And so that's also going to be exponential. Scenario 4 says Brianna opened a savings account with $100 with a 3% simple interest rate. And so whenever we have simple interest, that's going to be linear. So with that savings account, it is 3% of that $100 every single year. Scenario 5 says Jason takes 500 milligrams of Tylenol. With Jason's metabolic rate, the Tylenol has a half-life of 2.2 hours. So what that means is that at 2.2 hours, that Tylenol is going to be half the amount. And then after another 2.2 hours, it's going to be half of that. So we're decreasing by that same ratio of 1/2, and so that's going to be exponential. Scenario 6, Carson pays $70 a month for internet and $25 for each gigabyte used after the limit is reached. That is going to be linear. That cost is going up by the same amount for each gigabyte. Scenario 7 says Quinay opens a high-yield savings account with a 4.6% interest rate compounded daily. Whenever you see that word compounded, that's going to be compound interest, and that's going to be exponential. Okay, so now that you've kind of seen a gist of what some of these scenarios can look like, we've seen kind of some keywords that kind of give us a hint as to whether it's going to be linear or exponential. Let's go ahead and look at some tables. So let's take a look at these tables. You can go ahead and pause here if you need to, and go ahead and take a look at some of these, and I want you to decide whether these are linear or exponential and see if you can find that common difference or ratio. Alrighty, so looking at this first one, we see that the y's are increasing by 3, and so that is going to be linear. We are adding the same number every time, so that's going to be a common difference of 3. Then we have this example next to it. where we are subtracting 20 every time, so that's also going to be linear, because if it's adding or subtracting, it's going to be linear. So that's going to be a common difference of 20. And so when we're talking about common difference, they don't always ask whether it's positive or negative. That's going to come into when we are kind of doing our, when we're working on writing equations. But just the difference, they're usually talking about the absolute value. With our next one, we are dividing by 2, so this is going to be exponential. And that's going to be a common ratio of 1/2. So dividing by 2 is the same as multiplying by 1/2. And then our last one, we are multiplying by 2, and so that's going to be exponential with a ratio of 2. Alrighty, so now let's go ahead and start working on some equations and graphing. So exponential growth is when we have that sweeping curve that goes upwards. So it's increasing from left to right, and this is when b is going to be greater than 1. So when we think about multiplying something or putting an exponent on something, if it's going to be more than 1, it's going to grow. And so if we have something like y equals 4 to the x, we're taking 4 and then multiplying that by 4, multiplying by 4, multiplying by 4, and so it's going to get large very quickly. When we think about exponential decay, that is when our curve is decreasing from left to right, and that's when b is between 0 and 1, so it's going to be a fraction. So something like y equals 1/5 to the x. And so when we're thinking about 1/5 times 1/5 times 1/5 times 1/5, that denominator is going to get bigger, right? And so it's getting smaller and smaller and smaller, so that's why it's decreasing. But when we think about it, it never actually gets to 0. The numerator never actually changes to 0, and so you're going to see where that curve is going to start bottoming out, but it never actually reaches that 0, and that's called an asymptote, and we're going to get to that in a second. So let's do some examples. So let's say we have f of x, or y equals 2 to the x. 2 is going to be our b. Because b is greater than 1, we automatically know that it's going to be growth, and it's going to be increasing. When it's increasing, as x increases, or as we go to the right, y is going to be increasing, and then as we go to the left, y is going to be decreasing. And so now let's talk about how we would put this in our calculator. So we have y equals 2 to the x, and then remember how I said that our safe values to use for x are going to be -2 to +2. Can't go wrong with these. So we've got y equals 2 to the -2. And now I'm going to bring up my calculator. I'm going to pull it up just a little bit so we can see all the numbers. All right, and so when you go to put this in your calculator, let's go ahead and clear it. We're going to put 2, and then you're going to hit the y to the x button, and then 2, and then hit that plus to minus button to make that exponent negative, and then don't forget to press equals, and so that's going to give us 0.25, and we could always change that back into a fraction if we'd like to see it as a fraction, and then we're just going to keep going. And so now we have y equals 2 to the -1. So I went ahead and filled out my table, and I want us to take notice of this right here. So when x is equal to 0, that is going to be our y-intercept, and that one is easy because anything to the 0 power is going to be 1. So just kind of keep that in mind. So our y-intercept is going to be 0, 1. And then let's go ahead and graph this. And notice that when I graph this, don't forget that when we're multiplying, even if we had 2 to the negative 1,000, it's still not going to reach 0 because we're not changing that numerator when we're thinking about multiplying by fractions. And so that is called an asymptote. So notice that where our line begins to bottom out, that is going to be called our asymptote, where it's kind of going towards y equals 0, but y never actually reaches 0. So our asymptote is going to be y equals 0. When we think about our domain, it's how far is my graph going to the left and how far is it going to the right. So if we're going to the left, it's going towards negative infinity, and then we have it also going to the right forever. Now it looks like it's going upwards, but when we're actually looking at this graph, it is going to go up, but it's also going to go to the right forever. And so from negative infinity to positive infinity, that's going to be called all real numbers. And you might also see that with an R with a double bar here. So all real numbers. When we get into Algebra 2, that's where we start writing an interval notation, and we start using fancy words like negative infinity and positive infinity. But for right now, we're just going to say all real numbers. And then our range, remember, it doesn't hit 0, but it's everything above 0. So our range is going to be everything above that asymptote. And then talking about positive and negative, positive refers to whether our graph is above the x-axis, and negative is if we're below the x-axis and our entire graph is positive. And let's do another one. So looking at this one, if you have a fraction like this, I want you to throw it in parentheses, especially when you're working on that TI-30XA calculator on your EOC. So B is going to be 1/2. It's between 0 and 1, so that's going to be a decay. It's going to be decreasing. As we go to the right, and x is increasing, y is going to be decreasing, and then as we go to the left, y is going to be increasing. And then let's go ahead and start plugging this into our calculator. So we have y equals 1/2 to the x. So we have y equals, and then in your calculator, you're going to put parentheses 1 divided by 2, and then hit that y to the x button, and then put your -2. So I'm going to bring up my calculator. Let's turn it on, clear it out. We have parentheses 1 divided by 2, close parentheses. Then you're going to hit your y to the x button, 2, and then we're going to make it negative, equals, and that gives us 4. So I went ahead and finished out my table and made my graph. We can see that the entire graph is above the x-axis, so it's going to be positive. And just notice that your graph can be decreasing and positive at the same time. Those things are talking about two different things. So increasing and decreasing is talking about whether your curve or your line is going upwards or downwards. Positive and negative is referring to that x-axis. And then our y-intercept is still going to be at 0, 1, because we're just taking that number and putting it to the 0 power, which is going to be 1. So that's still here. our graph is still bottoming out at y equals 0, and it's going to look like it touches because it gets extremely close and it's just impossible for us to actually draw that by hand. And so that's going to be y equals 0. It's still going to the left forever and to the right forever, so that's going to be all real numbers, so you can put R with a double bar, and then the range, it's still above 0. All right, let's take a look at another one. So we have y equals 2 to the x plus 3. In this particular calculator, you can just type it as is. So you're going to put 2 and then y to the x negative 2, and then you're just going to put plus 3 on the end. And so go ahead and fill out your table. B is still going to be 2, and so that's going to be growth. If it's growing, that means it's an increasing. As we go to the right, y is increasing. As we go to the left, y is going to be decreasing. And then go ahead and fill out the rest of your table and go ahead and graph. So with this one, you want to take notice that when we have that x is 0, we have 2 to the 0, which is going to be 1, but then we're adding that 3. So 1 plus 3 gives us 4, and so that y-intercept is changing. So be careful with this one. And so our y-intercept is going to be 0, 4. Our graph is still above the x-axis, so it's going to be positive, but now our asymptote is also shifting, and that's going to be at y equals 3. Our domain is still all reals as it goes to the left forever and to the right forever, and then the range is going to be above that asymptote of 3. With this next example, we can see that our equations are getting a little bit more complicated. With this one, we have more than one thing in our exponent. So when you have that, make sure that you have parentheses around it before putting it into your calculator. If not, it's going to process that negative 2 as being out here, and that's not the case. So make sure that you're being really careful about how you plug this in, or you're going to get very, very different results. And so with this one, you're going to put 4 and then parentheses negative 2 minus 2. And then close your parentheses and press equals. So now I have my calculator open. I'm going to clear it. So we're going to do 4 y to the x, open parentheses, and then we have 2, make it negative, and then minus 2, close parentheses, and then press equals. As you are filling out your table, if it's a little bit easier for you, let's do this next one together. So we have 4 y to the x and then parentheses 0 minus 2. And if you were working earlier, you may have gotten some crazy decimals. You can always change them back into fractions. So say you have something like this, you're just going to hit second and then F to D, and it'll bring it back into a fraction. So you're going to hit second, which is the top left button, and then F to D, which is the bottom left button, and it'll take you back into that. So if that makes it a little bit easier to kind of conceptualize, then do that. So this is what I got in my table and on my graph. And so from here we see that B is 4. It's still growth, increasing, increasing from left to right, decreasing as we go to the left, positive, it's still above that x-axis. Our y-intercept in this case is 1 over 16, and so we have 1 over 16 here, and then our asymptote is going to be at our x-axis, and notice that this number here is really, really little, so there's just no way that I would be able to draw that accurately. But we can see that that 1 on top in the numerator is never going to go away. So our asymptote is still going to be 0. All real numbers, it goes to the left forever, and then it's going to be y is greater than 0 for this one. For this problem here, we have b is 3, and as we get to working on some of our newer equations for exponential functions, this is going to be a, and we'll talk about that in a little bit, but it's still going to be growth, increasing. These are things that we can already tell, and then from here, I know that my y-intercept, when I plug in 0 here, right, if that's going to be 3 to the 0, which is 1, I'm just going to be left with 2 times 1. So that's going to give me 0 and 2. And so that one's kind of easy to kind of guess. And then let's go ahead and fill out our table and go ahead and get this graphed. If you're unsure about how to put this in our calculator, what you're going to do is you're going to hit multiplication in between that 2 and that parentheses. So we have 2 times parentheses 3, close parentheses, y to the x, and then 1, and then we make that 1 negative, and then press equals. And then with this one, we hit second, f to d, and then it gave us our 2/3. And so I went ahead and filled out the rest of my table. My asymptote is still going to be at y equals 0. My domain is still all real numbers, and then my range is y is greater than 0. Just notice that that y-intercept changes, so just be really careful about these. All right, now let's try with this one. Now with this one, you're still going to put that multiplication symbol in between, especially when you're using that TI-30XA calculator. When you're using a graphing calculator, you do not have to go through all this. It's a lot easier to kind of see it, and you just type it out as is, and the calculator is really intuitive about knowing how to carry out the order of operations when you guys are doing these. But with that 30 XA calculator, you do have to be extremely careful. And so with this one, this is our A value, and that's going to come up later. Our B is still going to be 1/2, so that tells me that this is probably going to be decay and decreasing. It's going to go down as we go to the right and up as we go to the left. I'm going to assume that this is a positive graph, because it's never going to really multiply and give me a negative number, so that doesn't make sense. And then let's go ahead and fill out the rest of this table. When you guys are doing this, just make sure that you're hitting 3 and then hitting times and then parentheses 1 divided by 2, y to the x, and then put your number and then put that +4 on the end. So with this one, I can see that my y-intercept is going to be 0, 7. But with the asymptote, my table doesn't give me a super clear picture as to what it is. I'm guessing that it's 4, but to make sure, I'm going to put this into the calculator. And so this is something that I would do on my EOC just to make sure. So with this one, I have my formula, right? And so it's 3 times parentheses 1/2, close parentheses, and then I'm going to choose an exponent that's really, really big. And so I'm going to try 10 and then +4 and that gives me 4.00 and then a whole bunch of numbers. But that means that it's getting closer and closer to 4, but it never actually gets there. So it confirmed my suspicion that 4 is going to be my asymptote. So that's going to be y equals 4. And then my domain is going to be all reals. And then the range is going to be everything above 4. And so when I graph it, it's going to look something like this, where it's bottoming out at y equals 4, or approaching y equals 4, but it never actually touches. All right, let's go ahead and do our last one. So our last one, don't forget that we want to put parentheses around this because we have more than one thing in our exponent. So when we go to type this in our calculator, we're going to put 4 and then y to the x, and then plug in our x value in parentheses, and then subtract that 3 at the end. So when we go to type this in, it's going to be 4 y to the x, open parentheses, -2 minus 1, close parentheses, and then -3. So go ahead and fill this out and see if you have it right at the end. So this is what I got when I filled out my table and I graphed. One thing I do want to point out is when you are doing these, let's say the first one, we have 4 y to the x, open parentheses, 2 plus to minus, -1, close parentheses, and then -3. And so I get -2.984. And then to get that back into a fraction, I do second f to d. Now this means -2 and 63/64, so that's a mixed number. I can hit second ABC, and then it gives me this nice improper fraction. So that's how I got this number here. And if I'm not sure about where my asymptote is, so with fractions it makes it a little bit harder to see, even with some of those bigger numbers behind that decimal point, it's kind of hard to tell. So what I can do is I can put in a more extreme number, so 4 y to the x, and then let's take -10, and then -1, close parentheses, -3. And notice that it's still getting extremely close to that -3. And so that's how I was able to get my asymptote over at -3. So just kind of keep that in mind. You can put more extreme numbers in if your table doesn't quite show you what you need to see in order to write that out. So we've got this, and then it's still above -3 for my range. And so this is our last problem. So hopefully that helped you with identifying some key features, but also with how to graph, and especially with how to use this calculator for the EOC. And I'll see you in the next video.